everybody. Good morning. Chairman, good morning, ladies and gentlemen. Thanks for letting me be here and just share with you something different, okay? So I started a company called Technik with 3 other co-founders a bit too long ago. And I think I just want to share with you all who we are first. I'm not going to try and sell you anything, okay? So if you don't mind, next slide, please. Okay, we've got no focus in our life, okay? Yeah, it tends to repeat itself. Okay, so the focus is very simple. You can't imagine you do this as a mission statement. Our passion for high-performance engineering delivers world-leading solutions. What is high performance? Honestly, as time has gone by, we have moved our focus of business through the years. What I'm going to show you in the next few slides is exactly what forms our core and why we think the way we do and how it affects supply chain. Okay, next one. We are builders. We are very proud to be engineers. So what we do is we do mechanical, electrical, and software engineering in-house. We do everything from the fancy design work through to the welding of frames, spray painting of stuff, wiring the fella, and making things happen as well as maintaining them. Okay? So we've got 6 departments. I'm going to go through them very briefly, okay? So you understand exactly the background I'm coming from. We are cross-sectoral, so we serve basically all the sectors that have money, okay? Next one. Okay, so this is the first one. This is our DNA. We call this Technik Square, which we tend to call it our special projects department. So what do? We are engineering mercenaries. People give us money, we do the job, or at least we try to, okay? We have literally done everything from deep sea, surface, land, air, and space. And we have done everything from laparoscopic robots the size of my small fingernail through to platforms that weigh around 23 tons. Okay, so we kind of a bunch of real weird balls where one day, we're CADing and designing something and we're trying to find 1/10 of a millimeter to make something fit. And another day we can be off by 5 cm. Don't tell our customers, but sometimes the platforms are not very symmetrical. Engineering tolerance, we call it. Okay, so as this is now where we start going towards this supply chain and this technology side. So one of the things that we found many years ago was that there was this huge interest in drones, in unmanned systems and all. It reached a certain stage where we created a department completely focused on this. So if we rewind the clock into technology, I mean, today's the theme of this forum is fantastic, on robotics and stuff. There will be a lot of examples I'm going to share with you this morning on basically what happened if you rewind the clock. And this is really part of it. We did a lot of work for the militaries. We worked with a lot of military, so I can't tell you who we work for, okay? That old cliche thing, tell you, gotta kill you. I mean, it's really messy. If you look at the pictures, you see there's a helicopter there. That was one of the ideas that one of the militaries came to us and said, can you do a supply chain, from way back there, we don't want to fly our UH-1H or Super Pumas, can you do these kind of helicopters? And we ran these things. We ran this for almost 2 years for one of our clients. And so I will share with you very briefly the nightmares and intricacies. I mean, as we are technologists, the point that we come across is we'll tell you the exact pains. Now, when you start going towards platforms that size, immediately I'll tell you, you need to be an Air Force to operate something like that. It's no longer something that you put there, you light it up, you fire it up, and then you fly, and then it works. Our total weight with the payload that our client had with us was around 240 kilograms. So when that's flying overhead and we were doing something like 900 meters in altitude, as an engineer, I'm a mechanical engineer, the trajectory calculation says that if our engine were to fail and we had catastrophic failure and it landed on the roof, a concrete roof, it will punch through 2 stories before stopping. So you kind of suddenly start to respect these things. There are other parts of the legislative portion that you fear. I can't tell you again which country it was. So we wanted to do a trial before the big generals and ministers come, right? So we said, okay, we'll go to this quiet, empty field in the middle of nowhere and we'll fly it. So we did. What we didn't know was that it actually was large enough to have a radar signature. So there we were, very happy flying this aircraft, trying to do a practice for the big demo the next day. When my teammates turned to me and said, hey, bro, we've got a boogie coming at 2 o'clock. So, I felt very Top Gun there, like, okay, turn the bird, let's see who we got. So they did, and then we saw two attack helicopters coming in. We call it full tilt. That means, nose is down and they're flying as fast as they can. The next morning, it started with kind of something like a court martial going on, where basically they replayed the tape. It was to unknown aircraft. This is the Republic of so-and-so. Identify yourself, friend or foe. You are hereby invading sovereign land. So my point to this is you have to watch out in the logistics side, especially when we move towards robotics. You have to face a reality of certain things scaling. There are certain things which are really cool. Like we really wish we had 40, our prime movers? Everybody wants a prime mover that's autonomous. I know everyone's waiting for it. But this is a fine example of even with the military in countries which are relatively war-torn that we operate in. You still have to understand that there are fundamental limitations as things scale too much. Okay? Next, please. Now, we started doing all kinds of, we started going to AGVs. I don't want to sell you AGVs, I'm just going to tell you, it's a bit blurred, but you see the small little photo in the center, the yellow carpet. That is something that you all have to start thinking about as you adopt robotics. This is called adoption concerns. So last year at the launch of Singapore Smart Nation program with IDA, we were invited to use one of our AGVs to serve water to Prime Minister Lee Hsien Loong. Unfortunately, there's always a kick to something, right? Unfortunately, they didn't tell his security team that there was a robot that was going to be chasing after him and approaching him. So that was actually the best photograph that we had. And trust me, when he said, can I have a glass, can I have water? So he turned around, the robot started coming. And these guys, the security guys, let's be very honest, they carry this small little bag, and they put unpleasant stuff inside, right? Next thing you know, my teammates, the software guys, were making sure, we all had this emergency kill button in our pants pocket, all ready to press it, right? Next thing you know, we're being pushed aside, right? As this whole security team, all their hands started going into their bag, right? And I was like, okay, that is adoption concerns, okay? But on this point, on robotics, as we start introducing it into our workplaces, you have to remember one thing. We had a lot of customers globally that have asked us to make our AGVs and our robots move faster, okay? So my life before doing Technik was, I was a professional race car engineer. Yes, the most frivolous of all careers you can imagine. It's not marriage material. You go and meet a girl and you meet her parents and they ask you, what do you do? I'm a race car engineer. Equal playboy, okay? So it doesn't work. But anyway, back to that, I lose myself sometimes. I remember those days. Okay, the thing is that I came from the world of building things that really, we were paid to make things go as fast as possible. Now comes the flip side. Believe it or not, we have never delivered a single platform to any customer globally that operates more than 40% of its time at full speed. The reason is this. Even, I've got my teammates are showing one cute little small AGV that we have. It's one of the smallest ones that we do. When we are in this setting and everyone knows that the engineers are hiding behind the curtains just in case, it's one thing. When you start looking at it at 24/7 operation on a Sunday night when you're in some factory by yourself or there's a production line going on, and you see this AGV moving towards you with 400 kilograms, nobody can accept it. We basically found that the expectations and the trust that we have in machines is still not ready. I know that the world of robotics, I mean, KUKA builds fantastic robotic arms. We love to buy KUKA. I'm trying to say something nice because I'm trying to get a discount on the next KUKA arm that we buy. They move really, really quickly, mind-boggling. But that is in what we call a segregated environment. When, as humans, you don't stand next to it. Now, when you start seeing these robots start moving in the world that is coming, we have to start managing expectations. Trust me, there's another feature which is quite interesting. These AGVs, automatic guided vehicles, they start coming. Everybody says, oh yeah, your system doesn't use lines, doesn't do anything. Can it go around the object? The answer is yes, we can. We do it very well. Do we ever activate that feature? Seldom. Because what has happened is that we have found that as this platform moves towards the production operator, and the production operator stands in front of it and blocks the path of the AGV starts to turn and drive around. that means chaos. To anyone who doesn't know that the engineers actually planned for that robot to go off the path that they see it going every day, it basically means the robot has gone out of control in their mind. So believe it or not, after we spent, I think, a good 12 months perfecting that software upgrade. So we were so proud of it, and we went to the hospital and we implemented it for them. We left the hospital at 11 o'clock in the morning. At 2 o'clock in the afternoon, they called us and said, can you please shut down that system? They literally had nurses screaming. Because every day you start seeing the AGV stop in front of you, right? Today the AGV goes around you. It didn't help that it was the same week of Terminator Genesis or something, so, you know, they start believing that. Okay, next one, please. Now, this is just weird, just for fun. The fourth department that we have is special vehicles. For all of you who call Singapore home, things like the Red Rhino fire trucks are something that we do. So now you ask the question, how about the robotics portion, right? This is part of the scale of the business that we do. We build these things. I mean, again, I like welding, but I can only say that the majority of autonomous vehicles that we are seeing testing in Singapore have gone through our office. That's all I can say. So just to share with you, if you all want to know what it's like sitting in the back seat of an autonomous vehicle on a public road with the driver with his hands like that. Yeah, if you guys ever see it anywhere in Singapore of a driver in these autonomous vehicles and the guy's hands are doing this, this is called showing off, okay? It also means this is scare the living crap out of the guy sitting in the back seat. Because you look at it and then the guy starts turning around to you and starts talking very articulated and you see this traffic junction coming up. Yeah, that is things that I do as a job, okay? We carry spare underwear in the office because it scares the kabunas out of you. Okay, next one. Okay, so now, let's start the real proper, okay? So I just want to share with you what we do as a background so you don't think that this recruit here, you know, who's got day off from army or something like that, right, has gone completely nuts. Okay, let's start on this, robotics, the future of the Internet of Things, okay? Now, I'm going to tackle this in a reverse order because this was the topic they asked me to speak on. So let's start with the Internet of Things. I don't know whether you guys have tried to connect the dots and see what happened in where this idea came from. You see, a lot of things in technology actually came from the defense industry. They are the guys that spend an insane amount of money trying to make incremental gains, and they have a large amount of urgency. You don't believe it? We've got this plane called the F-35 Joint Strike Fighter. At the current moment, its development cost has just gone past $1.05 trillion. Okay, I don't know how you build a plane, but it's an amazing thing. Now, back to the point. So, many years ago, the militaries already wanted to see what every soldier was like, what they were doing. This was basically, if you ask me, humbly I'll tell you, I felt that that was the beginning of the Internet of Things. We saw a proliferation of that concept and ideas and the pain. It was no longer the first thing of GPS. You know, GPS started as a US DARPA initiative. That's how we had that. Then they de-encrypted it, let people know what on earth it is. It's no longer about just where the soldier was. It was the latest ones that we have seen, which are really, really fun. They want to know exactly what you're seeing. They want to know your heart rate. You know, we've done programs which are really fun. How many shots have you fired? When did you put it in automatic mode? When did you last clean your rifle? Okay. When you threw a grenade, how much stress did your heart go through? If you were shot, which part of your body was leaking the most amount of blood and which was the best drug that they had? There's one of them which is really fun. We didn't do this one. I heard about it on a visit to the country. So they put this patch there. There are needles put into your arm. So you get shot. It confirms that you're having this and you need an adrenaline shot or something. It will administer adrenaline for you so that will make sure that you survive. Okay, that's the morbid side of this. So if you really want to know, I feel personally that the Internet of Things really came around from these kind of ideas where there was such a large command control structure. You know, militaries are like this. The base is completely huge, wider than you can imagine, and the guy on top, the general, wants to know what every single person is doing. So that's how the beginning of Internet of Things happened. But there were challenges that came about it, and these are going to be challenges that we are going to see in the same time in the supply chain side. Okay, so let's go to a case study. Okay, this is arbitrary, okay? So that I respect the IP of all our clients. Let's just call it my container. So this is some ISO container that we are all used to. Okay, so this is a localized term, so they asked Mr. Tan to go to the yard. Can Mr. Tan please go to the yard, look for container A12345667, and find out whether the door is closed properly and whether it's locked. It sounds completely doable and plausible, okay? Stretch the imagination, and I hope Mr. Tan doesn't have to do this every day. Now comes this idea. So in the past, Mr. Tan would go out in the back of a pickup truck or a golf buggy or whatever it is and go figure it out in the big yard. Now comes this. This is where everyone starts going, I read something about the Internet of Things. Let's put a sensor on the container door. Makes sense, right? You put a sensor, by right, I should be able to look at this huge command control center, and I should be able to query A12345667, is my door open or not? After you have queried it, then people are going to ask this question, and I don't know where everybody is in this automation and this robotic side. They're going to ask this question, hey, since we can, find out whether the door is open, wouldn't it be nice if we could close the door as well? Sounds correct, right? I mean, that's how life is, right? People just get more and more demanding. Next one. Now, after a while, someone is going to ask in a number of years' time, an even bigger question. They said, okay, so what? I found out that my door is open. I press the door, ask the door to close. The door can't close, and I've put a little camera, and then I've realized that somebody has pried the door open and is trying to steal the stuff in my yard. Does that sound possible? Completely possible. So instead of now calling a group of security guys to go there and confront and apprehend this bunch of robbers, there is a potential that you're going to ask for this robotic team to go there and beat the living kahunas out of the robbers. Now, if you want to know, folks, this is basically, if you ask me in some weird form of prediction from a recruit, this is exactly what the industry is going to go towards. I know you guys are maybe not that interested in your 20-foot container, but face a reality. This is very largely what's going to happen. There is going to be a requirement creep until every part of the human interception and intervention required is removed. Okay, now, this is for dramatic reasons. There's a pause. Okay, I will go through this then. While he tries, it's a seesaw diagram next. I try to memorize it. So what's going to happen next is that it sounds fantastic. Now, first and foremost, there are two things that we need to address here. One of them is the Internet of Things. What is it? Internet of Things, at the current moment, is very heavy in the definition of data. We can take a lot of big data, and we can hope that we can execute on the data and act on it. So if you ask me, what is going to be is that it's called milk. Okay? The military likes to give us this term, which is called the milk. What is the milk? The milk, in the end, for all this thing of Mr. Tan's container problem, is you want that whole control per se. Wonderful. Thank you. So there you see, milk is at the bottom left corner. Okay, that's the benefits. We all understand that. Now, to sell this concept even further, we can talk about additional benefits. Additional benefits are going to be everything that you want. You're going to get trackability. You're going to get accountability. You're going to have the big data portion. There are so many hidden benefits that you can have when you start introducing all these items per se. If you want to know what is a slave driver, I'll tell you this. If you know when the door is open, you can also measure how long the door was open for. If you know how long the door was open for, you can find out which was the shift which was stuffing the container, packing the container for you, and you will also then know which is the most efficient shift. So you want to incentivize, and you want to reward, and you want to gamify this whole business of logistics, you need data. So you can actually see how just a door sensor per se could actually move into many, many different areas. You want to have speed. If you find that you have a problem that your doors keep breaking, okay, they keep getting dented, the handle area keeps breaking off, you can also find out how fast that door was closed and who closed that door. When you find out that, you will in the end find out that there is one culprit in your organization that is using a forklift fork to smack the door shut, okay? Because that's the fastest thing. And so the guy that's costing you all these container repairs is that monkey. Now, that is big data. This is Internet of Things. So those are additional benefits, okay? I hope you guys don't implement all of these things, because our office is in Penjuru. So maybe in a few years' time, when all these guys are incentivized and disincentivized because of this, and they find out, I think all that'll be left will be my hair. Okay, so quite dangerous. But now let's go to the other side. One of them is its quantity is cost. You have to be very, very wary of what scaling is going to be. If you say that you're going to outfit the container with a sensor, you have to ask yourself, how much is that sensor going to be worth? Okay? How much are you willing to pay for the sensor? Now, that is one thing that everyone looks at. They look at the capex cost and say, oh, wonderful, I think we can bite the bullet and let's go for it. Now, you've got to worry about cost and real cost. I have a big problem. My big problem is that as an engineer, I'm quite a lazy fella. So back home, when I've got a clock on the wall and the battery runs out and it stops moving, my wife always tells me, you're the engineer, go and change the darn battery. I'll tell my wife very calmly, no, the clock is perfectly accurate twice a day. Just twice a day, it's perfectly on the spot. So now, there comes a problem. If you look at real costs, okay, don't ask my wife what I really cost her. But if you look at the real cost then, if you allow the scaling of all this technology in such a wide area, please remember one of the biggest problems that we are going to have, and we will have for a very long time more, is its maintainability. This basically means if the thing is battery powered, you're going to be in trouble. I know we've got ultra low power draw devices and sensors and transmission and, you know, wonderful, low power. So how long will it last? 1 year? 3 years? In the industry that we are all in, 3 years is nothing. 3 years is going to be a pain beyond belief. What you're going to have in the end is that you're going to have an ancient system, which is like some old smoke alarms that you see in the buildings, which can never get changed, and all your capex budget has been used up because that fella is still stuck on that lock, okay? So do be careful very clearly on that long-term cost that you have. We can't really avoid it. And please understand, on the tech side, there are solutions, and no solution is really that great. We've tried energy harvesting before. That means when the container is on a ship and it's sailing, right? There's a nice rocking and swing, right? So we use solid-state devices there to generate electricity to try and charge back the device. It's a really cool idea. Does it work reliably enough? Honestly, data transmission, to send that data to let you know that Mr. Tan has been slamming the door really hard, or Mr. Tan is very slow to react and do stuff, that data transmission is very, very energy costly. So that's one problem. You're going to laugh if anyone says, hey, how about solar panels? Do you know in Singapore you see a lot of solar panels out everywhere for all the monitoring? Do you know when it is most inefficient? Or when a lot of problems happen to solar panels in Singapore? Those ones, roadside, you know, they are monitoring the drains to see whether they're flooding. You probably think it's December, right? Monsoon period, right? Yeah, it should be. Wrong. No, it's now. Okay? When we got really hot sun and everything is really hot, everything is really, really dry, and when there's no rain. When there's no rain, the solar panels don't get washed because the rain washes the panels. They're hydrophobic. So if you really want to know, you monitor, you go around the roadside, you're going to see a lot of guys coming around in white vans these days with big batteries, changing the lead cell batteries that are inside all these remote monitoring stations, and you will be shocked that they change it most often at this time of the year when everything's dry. So my point back to you is this. The technology, there are so many variants of technology, but you have to look in parallel. Whatever this industry is trying to achieve and do, and make all the cool stuff, you have to take one step back and ask yourself, has it been tried, has it been proven? Whatever we are trying to do here, somebody has done it before and made a big boo-boo out of it, okay? Next one. This is, I think, coming from a tech guy representing all the other guys in the exhibition hall to all the potential clients and current clients. Tech limitation is a real problem, okay? Fine example. We were asked by somebody, you can almost guess who, to automatically scan the barcode of a parcel, okay? Shipping company, 3PL, you guys can figure it out. Scan the barcode, robotically, automated. Sounds really easy, right? Well, you know, some places they do 2 barcode stickers. Some places they do 3. So everybody keeps talking about it as if it's a parcel that's going to come and the barcode is stuck there per se. If you actually try to figure out how to make a robot scan a barcode on a parcel which you don't know the shape of and you don't even know how to lift it, you are going to ask a technology company to hit you with a bill so large, it makes it non-viable. I give you this example. You think it's going to be a box with the sticker perfectly there. The first time we tried, we got a ball, a round ball, okay? When the person stuck the sticker on, the person tore the sticker. We had to find the other sticker. Now the ball wasn't a basketball. I wish it was. I've got no idea what it was. It weighed a lot, okay? And so this robotic arm was supposed to figure out how to roll the ball. You follow me, huh? Basically, mathematically, we were trying to tell the robot this. Shape, unknown. How do we now tell the robot that this is a ball it can roll? Because our actuator arm couldn't lift it. Okay? So we know that as humans, we would roll it. Try explaining to a robot, roll the ball. Roll, and roll in this direction, and don't roll too much because it'll roll off the platform and we'll be in trouble. You guys follow me on this? Okay? Now, these are real problems. Do you know what is, when tag is not a limitation? It's called an RFID tag. You think we care? Honestly, do you really think we care what happens? No, we just, the ball comes through this little ERP gantry. Hey, we got the data. We know exactly which parcel it is. But there are going to be a lot of things that we're going to face legacies with. Barcode is a very graphical example. And to try and then migrate and make the technology work for something of this legacy, this is where we now have to ask ourselves, are we going to change it? This is where you either going to have to adopt a wait-and-see approach. That means let the world figure out what they're doing, okay? Or make a change on your own. You have to decide, okay? But don't take a middle ground and ask technologists, any technology company, and say, please solve this problem. Because if you ask them, please solve this problem, I think you're going to end up with this roll the ball problem. Okay? Roll the ball problem, next thing is you want infinite amount of energy that will last forever. You guys all can figure this one out, right? So now, what is the solution? I like to bring doom and gloom on a Wednesday morning. I thought it's Monday. Sorry. Okay, next one, please. Shazam. Now, we start moving towards the current state of play. There is a difference between automation and robotics. The biggest difference is automation is very structured, it's repeated, it's repeatable, and there's no freedom per se. Robotics is not. That's one of the drones that we build. We build a lot of drones. We are effectively the largest UAV manufacturer in Singapore. We do them by the dozens. We actually do them by the hundreds per se for very specialized clients. So the UAV is a robot, true or false? True, right? UAV is a robot, right? I know my colleagues are going to kick me. I'm lucky that they're behind the door, and I hope those ladies and gentlemen behind will keep the door closed. To me, a UAV is not a robot. It is not a robot. Which part of it is adaptable? Which part of it self-learns? Which part of it does something that you didn't tell it to do? You see, everyone believes that we have actually seen the robotic revolution come. I can tell you, no, it didn't. This kind of quad rotors that now you're buying, and trust me, it's really hard doing this business. When we started doing it like 7 years ago, we sold it to the militaries. They were so excited. Now we bring that aircraft there. The guy says, my cousin's one are even bigger than yours. Okay? It's really difficult doing that business. But the point is this. Look at the aircraft. When I was a kid, 5 years ago, these things already existed. They had a very short battery life and they were very expensive. There's a Japanese company called Keynote that did it, okay? Now you see DJI, you see it, you know, Q10, I think my colleagues love buying it, you know, these small little multi-rotors. And by God, when they wait for this special discount, they don't buy one. They are boys, little kids who are overgrown like myself. They'll buy 10 because everyone wanted to just take it and throw out of the window and see how they fly. I usually wait below with a big net. I get them for free. This point, on the UAVs, no, they are not robots. Okay? They are basically an automated system. They have taken most of the flying requirements and stabilization out of your hands, and they do exactly what you do. A lot of them do this waypoint navigation, right? I set a GPS coordinate here, I click the map, I click the map, I click the map, and then you show your friends, look, this is my robot. Flies, and whoo, you see, waypoint 1, waypoint 2, waypoint 3, waypoint 4, come back. You ask it to do it again. It does exactly the same thing. That, ladies and gentlemen, is called automation. So it's going to change. Okay, next slide, please. What to expect? This is my last slide. Okay, this is something, again, I'm taking the leaf off from the military side. Okay, so what happened is this. They asked us to solve this problem. Can you actually show us a robotic system as a concept? And this is what we came up with. We called it SWARM. So what happens is that if, let's say, this table were our objective, our target, so we'll say north, south, east, west, I want one aircraft to look at it at any one time. Sounds good, right? So everybody here brought 2 drones, and wherever we were in this huge training area, we'll take the drones and we'll just throw them and we'll power them on and we would walk away. Now, when the big commander said, I want to see north, south, east, west on this table, activate, we called it Skynet. I mean, we've got no imagination whatsoever. You know, I really love that music that you guys started with. Okay, so what happens is that the best drone, the best UAV would actually take off, would actually proceed to the objective. We didn't tell it how to fly, where to fly, that didn't matter anymore. It would do the job. But that was not the big thing. The big thing was this. When one of them's battery was running low, it would know who is the next aircraft which is best suited to take over its job. The next aircraft will automatically be summoned. It would take off, and it will fly behind the fella. The first aircraft would fly away, and the next aircraft will replace it. And on our devices, the video that we saw, we just saw it. That's it. We changed from one video camera to the next. Did we even know which aircraft was flying? No. Trust me, when you're doing the test, it is the scariest thing you can imagine, because engineers, you know, we mass produce things, right? So they look exactly the same. So you've got all these safety pilots and all the software guys, right, looking there. And we're like, aircraft 16 is en route to north. Then you always hear these software guys go, hey, which one is aircraft 16 now? Is it the one on the left, the right? You know, these things happen, okay? But back to the point. So it will automatically replace them. Same thing as if they were to have gotten shot. There are 2 things that scared everybody. The first thing was we made it decentralized. This is another point that I need to bring across. For mission criticality, you don't really want a single point of failure. Everybody expected us to go up with this huge lorry, and in the back you have all these computer racks with all the data flowing and stuff like that, and command control of everything. That's your traditional, I give you a dot, I draw your web, everyone listens to the web. No, we decentralized it. That's why we called it Skynet. We created, you remember just now I talked about that ball rolling? We teach computers a mathematical answer to everything, and they use a maths algorithm to transmit what we like to blasphemously call the religion. So the religion is actually the mission. And so what happens is that to destroy Skynet, as in the movies, we had to destroy every single element. Okay? If you really want to know what robotics is, that is the beginning of robotics. But that is not the end. We started, we never, I officially can't say we did the test, but you'll read from here. Without adding any sensors, we knew how long the aircraft, one aircraft would take to fly northwards. We would know how long it took for another aircraft to fly southwards. We would know it by GPS, right? We knew time on target. What did we know after this? We found out the wind direction. That is the beginning of big data. That means if you take every bit of data that you have, you could actually figure out a lot of things that you never thought you could figure out. So basically what happens is that if we needed an aircraft urgently on the northern face, We would know that if the wind was blowing north to south, we would command the aircraft on the north to take off and fly with the wind, and your station keep there perfectly. So that's the beginning, the problem that we have of big data per se. These things are possible. Now, I flip you to the supply chain side. When we do stuff in things like, let's say, hospitals, okay, generic example, what we are going to see is, we are going to see the Internet of Things. We are going to see a lot of sensors throughout the hospitals per se. Anytime, okay, I hope hospitals are a neutral example. We'll figure that one out, okay? Anytime you have got 230 volts and you got power and electricity everywhere, your life is good, okay? Welcome Internet of Things. Your battery, everything is going to work perfectly. It's a controlled environment. It's scalable. It works. So you've got that. The next thing you're going to see is that you are going to then have all the data come in, and you're going to need robotics to react and act on it. Now, the traditional way is to believe that there's a path and a mission that the robots are going to do. Answer is no. When we created this, I know this sounds like a very Sarah Connor thing, when we created Skynet. What it basically means is that if you know that a hospital has got 5 different ways to get to a ward, from let's say the kitchen to the ward, and there are 5 different avenues, folks, please get ready for the point in time where we have enough data that we know exactly of the 5 routes, which is the one which is least crowded, and so that it means that our food cart can go, the AGV can go up, take the lift, go down this corridor. Instead of going directly, shortest path, it takes this long meandering road through the back, right? Through the mortuary, so that you can avoid everybody. Yes, don't laugh. We did find that the fastest way around the hospital is always through the mortuary. Okay, it's just amazing. Nobody goes there. Like, nobody. Anybody you see moving there, it's, thank God we are sending the robots, not us. So we remotely see it, and we're like, oh, there's someone moving there. Do the legs actually touch the ground? Anyway, okay, so on that bombshell, this is what you're going to expect. You're going to expect a lot of data coming in from the Internet of Things, okay? And the next thing that you're going to expect is you're going to expect robots to act on them. The way the robots are going to act is not something you've seen before. You are going, what to expect, as I conclude, is the robots are going to do things that you didn't expect or you didn't program it to. That is the foundation of the robotics that we are going to see. So if we can, the forward-looking view of it is going to happen whether we like it or not. We just hope that things like Skynet, don't wake up and start trying to get rid of us. But if not for that, get ready for it, and that is where the future is going to be. With that, thank you very much, everybody.
Thank you, Peter. Cannot go, we still got time. Still got lots of time, so keep it on. Okay, so Peter, we just end with that one, right? And I'm going to ask that question about robots tomorrow. And I know that the robots tomorrow, I asked you that question. How long do you see before that robots of tomorrow who can behave like Skynet happens? Wait, let me see a number. Number 3. Come. We sit down here, easier.
Okay, not bad. Okay, the movies actually make them look really cool. Don't expect a lot of... The robots aren't going to look like what the movies sounded to be, okay? I know I'm going to sound very rude on this. Anytime you see a robot with eyes and looks cute moving towards you, right, I don't think that's the direction people are going to go, okay? We have seen a lot of social robots before, okay? They're very popular in Korea and Japan. I hope I don't step on anyone's toes when I say this. It's really hard to justify it because what they're doing is they're bringing an iPad screen to you, and then they are doing FaceTime with you, and that's not really something, there's no real technical advantage. I think what you're going to see for the robots in the future is they're going to see manipulator arms on a dirty platform, and you're going to see a very awkward-looking head, okay? That's really what you're going to see.
Not as nice as something like this.
No, the knees are exactly like mine. They're very skinny, so not very strong. But unfortunately, you won't see this. You will see this for education side, but I don't think the robots are going to look anything like that.
Okay, sounds interesting. So I I term the robotic revolutions as disruptive technologies, and I actually believe that you're going to go on with me for this, right? So to me, disruptive technologies essentially level the playing field in the world. So technologies has always been so-called the whole of USA or even Europe. So those companies coming out from there will design something like this, disruptive technologies, good IP, and then get lots of adoption and then become multi-million dollars company like the Google. So are we seeing revolutions that allows even play in Singapore, even a play like Technik coming on board? Can we be a player in the world?
As a technology company, I have to tell you, yes, we really believe we can do it, right? If not, I don't know why we are going to work on Monday morning. The business is different, folks. We are not talking about Henry Ford's time building a car that we need a few, in today's dollars, billions of dollars to create a new automotive giant. I give you this example. Look at Tesla. Tesla's value is half of General Motors, is half of Ford. What did they do? They revolutionized the whole manufacturing process, and really their core IP is that battery technology, that motor drive system, this electric guys, Tesla. If you look at how they update the cars, everything is of firmware. It is by the internet, it's by the cloud. It does maintenance, it does built-in tests remotely. What's my point here? This industry of robotics is going to see players that you don't know where they exist. You look at the buys of Google 2 years ago. Google bought 11 companies. They spent a few $1 billion buying even the likes of Boston Dynamics. How on earth did Google need to buy a company like Boston Dynamics from MIT? Why did they need to do that? It's because that capability and technology can now come out in the smallest outfits. We are going to see a guerrilla war here. But what we will see in the next few years is what has happened in the aviation industry and the auto industry and everything. Now, we will see the guerrillas. The guerrilla warfare is going to happen throughout the world. Many companies, countless companies, small companies. Give them another 10 years to 20, to at most 10 to 15 years, and you see consolidation. Then the small companies are all going to be merged, M&As are going to happen, and then you're going to get new incumbents, the new big boys. This is going to happen. The whole UAV market has already happened, okay? It's already in process.
The last question. So would that happen to Technik? Is Google talking to you?
No comments.
Thank you, Peter. Thank you. Thank you very much.